Blue is mass 1, and we want an equation for mass 1. Well, we're going to use Newton's law. Newton's law states that net force equals mass times acceleration. Which mass are we referring to? Mass 1. But we need to know a little bit more about what the forces are that are causing the net force. What forces are involved? It's motion. That would be Jack? There's no friction. And go ahead and put them in the correct order. Oh, okay. We don't know, do we? Because we don't know which way it's moving. So now it's time to decide which way it's moving. So right here is where we decide. And if you forget to decide, you should realize at this point because we don't know what the order is. So it's either moving down or this is moving down. There's only two we have to look at. Kyle, you got any ideas? Not necessarily, because here's why. Y'all heard Kyle said the bigger mass should be the one that wins. But there's only a component of the bigger mass that's actually working to move it down the incline. And what is that component? Which is 18.62. What is the force that's causing the other one to hang? Ah, it won. Yes, ma'am. I can. She is on. Yep. See ya. All right, so at least this is where we're at. I'm recording it, put it on the website. You'll be good. Exactly. So, since FG of M2, is that confusing? FG of M2. The gravitational force of M2 is greater than F parallel the system moves up the incline. I probably could have worded that better, but you got the idea. Okay, so that's a fact, Jack. That's the fact, Jack, that we need to know the direction. So there's only two things that we're looking at. It is this and this. Okay? The winner of that is the direction it goes. If friction were involved, we'd have to incorporate friction as well. Okay? But there weren't in this case. Robert, question? No, I've actually got it pointing down. So that is the gravitational force, F sub G. That's F G. Gravitational force. All right, now we go back over here, and we can do our equation. Net force is the sum of all forces acting in the direction of its motion. Yeah. More accurately, the plane is because it could be opposite direction. So back to Jack. T minus F. And since net force is M1A, we can put them together and say M1A equals T minus F parallel. Okay, now we go to the red, which is our M2. And we do the same thing. Net force equals M2A. The sum of all forces that make that M move are what? F, G, and T. In what order? Yep. So that's M2A equals FG minus T. And we have F parallel and L. You could probably keep those separate, not get confused. But if you're ever wondering which FG you're talking about, because there is an FG here too, right? you could actually write it out as m2 times gravity. If that helps. Yeah. Sigma F. Yeah. Now, what do we want to solve for? It says we want acceleration. That's what the problem says. We want acceleration. And we've already answered B, by the way. In what direction is acceleration at M2? M2 is accelerating down. Okay, now A, what is the acceleration? What do? Isolate for A? We're looking for A, so we should isolate T. If we isolated A would go away. So we want to isolate T. Jack amused himself. That's so cute. So let's isolate T. T equals M1A plus F parallel. Over here, we got T equals FG minus M2A. Then I'm going to substitute. I'm going to mash them, my friends. That gives me M1A plus F parallel equals FG minus M2A. And I'm about done. I just might as well clean it up and solve for A. So that's going to be A equals FG plus, FG minus F parallel all over M1 plus M2. Okay, I just kind of skipped a step, went right to it. We've seen that a few times. Now, before we start plugging in numbers, let's think about this a minute. Look at the equation and just think about it. You can memorize this if you want. They're not going to always be the same. So I wouldn't get hung up on it. You also have to show me the process. But let's see if it makes sense. You go through this whole process and you want to know if your derivation made sense. FG minus F parallel. What did we say that tells us? That kind of told us the direction. FG was greater than F parallel. Over here, FG was greater than F parallel. So that told us the direction of the whole system. So we're saying that the difference between those two forces divided by the sum of all masses is the acceleration. It's easy. Robert. How the mass of number 2, because what's going to make this go down? Gravity. So we've got, you're just easily amused. You dropped a pen. You watched Beavis and Butthead earlier years, didn't you? I did too. Okay, so you drop the pen, the gravity pulls it down. So gravity's pulling this mass down. We call that FG, gravitational force. Okay? Now, what's pulling this mass down? It's not all of FG, just the parallel component of FG, which is 18.62. So, Robert, since there's no friction, the greater number wins. The 20.58 is greater than the 18.62. It's as simple as that. Yep.
So the force of gravity is...
Okay, yep.
Oh. Okay.
I was looking. You couldn't tell who I was looking at.
No. Oh, okay.
Oh, let's just all hold hands.
Okay, so FG is only useful in solving for the other forces, and it's not useful in the problem itself, except for the substitution. Like,
I did not understand that at all. FG is very useful,
yeah,
and FG
but,
is the love of my life. So don't talk bad about FG. FG is Newton's second law,
yeah.
but the acceleration is always the same as gravity. It is used in multiple places. It's used on an individual basis here, but then it's used on a big scale for the net force. So what does this say? Okay, y'all gonna like this. All right, what is Newton's second law? This is like a little side thing. Newton's second law is F equals ma. Rearrange equation, solve for A. Oh, what do you know? F over m. It's net force over all the m's. That's still Newton's second law right there.
That's cool.
That is very cool. Chill bumps. Whoa. Robert? Net force is never equal to normal force. Perpendicular force is sometimes equal to normal force. Normal is a contact force. And so this box is pushing down on the ground and the ground's pushing back. How much is it pushing on the ground? We call that perpendicular force. It's a component of gravity. All right, so then we just finished out the problem. Oh, no. No problem, I'm back. No problem. Okay, so FG is 20.58. 20.58 minus, can't remember, 18.62 all over 33.8 and 2.1. 3.8 plus 2.1 equals 0.33 meters per second squared. And